If you think this takes skill, imagine trying to lasso a satellite in space. Now imagine flinging that satellite up to a higher orbit. That's what a small business in Linwood, Washington is planning to do. The researchers and engineers at Tethers Unlimited Incorporated, or TUI, are not cowboys, but they are developing lassos, new systems that will be used to capture as well as launch spacecraft.
In one application, it's sort of like a lasso or more like a sling, where you'd have a very long string or cable in orbit that's rotating as it orbits around the Earth, and it could swing down and pick up a spacecraft in low orbit and then carry it up and toss it into a higher orbit.
For founder Rob Hoyt, it all started while he was still in graduate school. He shared an interest in space tethers with Dr. Bob Forward, and the two eventually formed the company. Not long after, TUI began working on a NASA project with an award from the Marshall Space Flight Center through the Small Business Innovation Research, or SBIR, program. The company developed the Hoyt tether. With multiple interconnected lines, the Hoyt tether is like a giant fishnet stocking. Today, TUI is collaborating with the Air Force Research Laboratory to refine the Hoyt tether. A few years later, Marshall funded TUI to continue its work. The company then created the Terminator tether, a cost-effective method for removing space debris.
It can deorbit the spacecraft with a much lower mass requirement than a rocket. And also, the tether system is basically self-powered, so it can deorbit the spacecraft even if the spacecraft is dead.
The firm has also teamed with Stanford University on a Small Business Technology Transfer, or STTR, award from Marshall. They're developing a flight experiment called Multi-Application Space Tether, or MAST. MAST will deploy 3 mini-satellites along a tether to study how well tether propulsion technologies hold up in space. And with the Langley Research Center, through another SBIR contract, TUI is partnering on SensorLine. This product will enable spacecraft to deploy distributed arrays of microsensors on planet surfaces. The microsensors would perform a variety of experiments, usually done by more expensive robots. Through the In-Space Propulsion Technology Program, NASA is funding TUI to produce key technologies for a momentum exchange electrodynamic reboost tether system called MIXER. MIXER will deploy a 100-kilometer-long cable in orbit around the Earth. Hoyt says it'll be like a railroad in space.
So it's a way of boosting multiple payloads from low Earth orbit up to geostationary orbit or to the Moon or possibly even to Mars without using any propellant.
The firm's greatest obstacle to space tether development is flight testing. So in the near term, TUI is using microgravity test environments to prove their systems work and can be operated successfully. Although theirs is a niche market, TUI knows what it takes to be successful.
You need to look for other markets for your technology or your skills that may not be entirely obvious.
Realizing they were already analyzing and simulating many strange and complex space objects, they decided to form a division called Science Ops.
It's a very different market from our core market of space tethers, but it utilizes a lot of the same skills that we utilize in our space work.
With more than 8,000 satellites and other large objects orbiting the Earth, and with more being launched, TUI is positioning itself to be ready with timely, low-cost solutions for lassoing satellites.